So for section 10.2, we're going to be looking at graphing quadratic equations, and I'm going to be showing you two different ways to graph quadratic equations. So what you see on this slide are the two different ways to graph quadratic equations. So the first way is called standard form, and with standard form there's no parentheses. It's actually just ax squared plus bx plus c. The way you find the vertex from standard form is you take negative b over 2a, and then for the y, you just plug that in. And that's how you find the vertex of that parabola. For vertex form, the way you actually find the vertex is you pull it straight out. The h happens to be the x-coordinate of your vertex, and that k happens to be the y-coordinate of your vertex. So you pull that vertex directly out. So let's take a look at a specific problem. When you have this is standard form right here. So the first thing that you want to do is identify your ABC. So my A is going to be that 1, my B is going to be that -6, and my C is going to be that 5. So the first thing I want to do is find the vertex. And if you remember correctly, vertex is negative b over 2a, and then you plug it in. So the first thing we got to do is find negative b over 2a. So -6 is positive 6 over 2a, or 2 times 1. That is a 3. That is the x-coordinate of my vertex. Now I'm going to take that x-coordinate of my vertex, and I'm physically going to plug it back into this problem up here to get my y-coordinate of the vertex. So instead of x squared, it'd be 3 squared, which is 9, minus 6 times 3, which is 18, plus 5, giving me a -4, making my vertex 3, -4. Now the other thing that you also found is the axis of symmetry. Axis of symmetry. And we shortcut this AOS. The axis of symmetry is always the x-coordinate of that vertex. If you come over here into your graph and we look at where x equals 3 right through here. And axis of symmetry is not actually part of the graph, which is why we dash it. We don't actually make it a solid line. And then it's always a vertical line. So x equals 3 is always a vertical line. Basically what that means is that's going to cut the parabola in half. If we were to cut this parabola in half, it would be cut straight on this line. Your vertex should be on this line. In this case, it is. It's right here at 3, -4. So I know half of my parabola, is going to be on this side. The other half of my parabola is going to be on this side. I also know my parabola is going to open up because my A is positive. So I know that it's going to look something like this. I just don't know the exact points. So from there, what we're going to do is we're going to actually create a t-chart and find the rest of our points. So if my vertex is at 3, -4, what I want to do is find 2 points lower than that, so like 2, 1, and I want to find 2 points higher than that, so like, for example, 4, 5. And then what you do is you physically just plug those in to this original problem way up here and get your y-coordinates. We're just using a t-chart. So if you plug in the 1 correctly, you're going to get a 0. If you plug in the 2 correctly, you're going to get a -3. Then you got your 3, -4. 4, and then -3, 5, and then 0. So if we go into our graph and graph those, we have 1, 0, and 5, 0. And then we have 2, -3, 4, -3. So it looks like it's going to look something like this. Now remember, it curves. It's not a V. It curves at the end, making it almost a U shape, which can be difficult to make. And that's my parabola. It is graphed. Okay, let's go ahead and look at this problem. Now this problem is actually written in vertex form, which means to find the vertex and coincidentally the axis of symmetry, I'm going to actually pull it straight out from the graph. It's going to be pretty simple. So the x-coordinate of your vertex is the number attached to x, and when we rip it out of those parentheses, we change the sign from a -3 to a +3. The y-coordinate of your vertex is this number outside. Since it is not in a parentheses, we're not ripping it out of anything. We just carry it down as a -4. So you change the sign of your x, you don't change the sign of your y, making my axis of symmetry x equals +3. Just like the last problem. Now, remember, axis of symmetry, we dash it because it's not actually part of the graph. And our vertex is 3, -4. We go and create our t-chart, just like we did on the last problem. Remember, 3, -4 needs to be in the middle, and we need to choose 2 points that are lower and 2 points that are higher. When you plug that in and get it, you get exactly what we had on the last graph. And that is just coincidence. and then you'd graph your parabola using your 5 appropriate points in your vertex and your axis of symmetry.